Assalamu alaikum everybody. I am Muhammad Abubakar. Today we're going to solve the reaction kinetics A levels AS P1 topical, and this is of 36 MCQs. So without any delay, I shall be starting the video here. So yes. Question number 1 says the Boltzmann distribution for a gas at constant temperature is shown below. If the temperature of the gas is reduced by 10 degrees C, the graph changes shape. What happens to the value of n for the points marked X, Y, and Z? Now, for the number of molecules, what happens to X, Y, and Z? Now you are reducing the temperature, means that the kinetic energy of the particles is reducing. The kinetic energy of the particles is reducing, means that the molecules present at this side, or you can say at this side of the graph, they are now decreasing because you have reduced the temperatures. And the maximum number of particles possessing the maximum kinetic energy will also decrease because you have reduced the temperature. But the particles having lesser kinetic energy, on this graph, this is of the lesser kinetic energy, this is somewhat higher, and this is the highest. We have been given the 3 points X, Y, Z, so we have only to check them. So for X, the kinetic energy is lowest, so X would increase because you have reduced the temperature, so X would definitely be higher. Y would be lower, and Z would also be lower because you are now reducing the number of particles which possess more kinetic energy. So B is your right answer. So we move on to next part. Okay, then now he says, in the Haber process for the manufacture of ammonia, why is the heterogeneous catalyst iron in a finely divided state? Okay, so now let's check the options. To increase its surface area, yes it is. To produce the maximum reduction in activation energy, no, 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 no. It would still cause the same decrease in activation energy given the conditions it is in the powdered form or it is in the solid. To reduce its loss during the dilation, no. To reduce its surface area, no. A is your right answer. B is certainly not possible. You are gonna go for A, to increase its surface area so it can catalyze the reaction the most, because it will now be more exposed to the reaction mixture, unlike part B which says produce maximum reduction in the activation energy. This is incorrect. Okay, so now we are gonna do part 3. The molecular energy distribution curve represents the variation in energy of the molecules of a gas at room temperature. Which curve applies for a gas at a lower temperature? Now this is same as the graph in question number 1. There would be more molecules possessing lower energy. There would be more molecules possessing lower energy, and there would be lesser molecules possessing higher energy because you have now lowered the temperature. So this is simply C. This is similar to question number 1. You can see it if you want to beautify your concept. Anyways, so question number 4 says, which factor can affect the value of activation energy of a reaction? So increase in temperature, decrease in temperature, temperature never affects the activation energy. The presence of a catalyst, yes it does. So D is your right answer. A is also incorrect. Concentration has nothing to do with activation energy. Question number 5. Question number 5 says, the diagram shows Maxwell-Boltzmann energy distribution curves for a molecule of a sample of a gas at two different temperatures. Which letter on the axis represent the most probable energy of the molecules at the lower temperature? At lower temperature, more molecules will be possessing at lower temperature more molecules will be possessing a lower kinetic energy. So this is the energy on the x-axis here obviously, and this is n, which is the number of molecules. So this is definitely this curve, the curve which is a bit more in height. Now be careful while selecting the axis. You are gonna go with C because the x-axis represents the energy. The A shows the number of molecules which possess C energy at this lower temperature. So C is your right answer. Be careful of the axis. So question number 6, an autocatalytic reaction is a reaction in which one of the products catalyzes the reaction. Which curve was obtained if the rate of reaction was plotted against time for an autocatalytic reaction? For an autocatalytic reaction, the product catalyzes the reaction. So this is something. This is definitely not A or not B, because they both show that the rate increases and then the rate becomes constant. This is not what is happening in the autocatalytic reaction. And whereas in part C and part D, you are gonna go with C, because you know the products are catalyzing the reaction. So when the rate increases, when this rate increases, so till then the rate of the reaction increases. But when the reaction end, what would the products catalyze? There is no substrate, oh sorry, there is no reactant. The products will obviously catalyze now. So over time the rate increases due to increase in product concentration, but after some time the reacted molecules, the bio students, they will more likely understand this. I'm trying to say that the substrate molecules will be limiting here, or you can say the reacted molecule will now start to limit, so the rate would fall. D is incorrect. Why? Because the rate initially was higher, and this shows that there was no presence of product catalysis here. So D is definitely incorrect. C is your right answer. So question number 7. Okay, the diagram show the Boltzmann distribution of air at two temperature. The solid line represents the distribution at -20 and the dotted line represents a distribution at -10. Which diagram is correct? This is a piece of cake, literally. Why? Because the molecules at -20 mean they are at lower temperature. Definitely they are gonna possess more number of particles with lesser energy. They're gonna possess more number of particles with lesser energy, unlike the dotted line as shown here. So the only graph you're gonna select here is D. This is same as question number, I guess, 4, no, 3 and 1. So why I have gone with D is because the number of molecules at -20 degrees C possessing lower energy is higher as stated in the graph D. So D is definitely your right answer. Question number 8. The graph shows a Boltzmann distribution of molecular energies for a gaseous mixture. The distribution has a peak labeled P on the diagram. What happens when the temperature of the mixture increases? What happens when the temperature of mixture increases? We have number of molecules, we've got molecular energy. The activation energy is definitely going to stay the same. And activation energy, temperature has nothing to do with activation energy. The height of peak P, yes, this would decrease because now there would be more molecules possessing higher energy. There would be more molecules possessing higher energy, so height of P would decrease. So C is your right answer. Question number 9. The diagram shows a Boltzmann distribution of molecular energies for a gaseous mixture. The distribution has a peak labeled P on the diagram. What happens when an effective catalyst is added to the mixture? And when an effective catalyst, now he is talking about catalyst unlike the temperature. So the activation energy, first thing you add a catalyst is activation energy shall reduce. So activation energy is gonna move to the left, so A and C are automatically wrong. And what would happen with the height of the molecules? Now you are not changing the temperature, and the number of molecules possessing the same energy. Yes, the number of molecules would be possessing the same energy. You are not changing the temperature, You have only added a catalyst. Catalyst has lowered the activation energy but doesn't cause any number of molecules to get lesser or to gain some energy. So this doesn't happen. So the height of the peak remains the same. Catalyst has nothing to do with the number of molecules associated with their kinetic energy. So D is your right answer. Okay, so now question number 10. The diagram shows the Boltzmann distribution of energies in 1 mole of a gas. This gas then can take part in an activation in a reaction with activation energy EA. So which statement correctly describes the effect of an increase in temperature? Now the activation energy, what will be activation energy? Activation energy shall stay the same, and now you are increasing just a second, you are increasing the temperature, so there would be more molecules at this part of the graph because now they possess more kinetic energy. So peak P is definitely gonna be lower. It is definitely gonna be lower, and now you have increased the kinetic energy. If you increase the kinetic energy, you write in P2 answer that you increase in kinetic energy, so the molecules gain sufficient activation energy to react. That's why the rate of reaction increases when the temperature increases. So more molecules will have an energy greater than the activation energy. So this is what is happening here. So D is your right answer. All right. Question number 11. Enzymes. Enzymes are biological catalysts. Everybody knows this, and O-level students must know this. Many enzymes show specificity. An example of an enzyme which shows specificity is glucokinase. Glucokinase is involved in the metabolism of glucose. What does the specificity mean in this context? Now the bio students can relate to this. Specificity means the active site has a specific shape to which the substrate molecules are attached. So let's check in these options. Glucose is most effective catalyst over a narrow pH range. This is of the optimum pH. This is of the optimum temperature. Glucokinase provides an alternative route for the reaction it catalyzes. Yes, it does, but this is not in the context of specificity. While C is your right answer. Why? Glucokinase only operates on a narrow range of substrate molecules. It only catalyzes a smaller number of molecules. That is why it is it is specific to glucose. So C is your right answer. Okay, now then read question number 12. When 4 gram of powdered calcium carbonate MR100, so this is, just a second, this is 0. 0.04 moles of calcium carbonate were added to 100 cm cube of 0.1 mole per decimeter cube HCl. So this means 0.01 mole. Try these formulas and calculate your non values. These must be equal. When these are added to this volume, okay, the volume of carbon dioxide produced was recorded. So it was 40, then 70, 88, 100, 110, 116, 120, and then it becomes constant. Okay, now CaCO3 reacts with HCl to give CaCl2 plus H2O plus CO2, and the mole ratio is 1:2, means that 1 mole of calcium carbonate shall react with 2 moles of HCl. So HCl is the limiting factor here. So first thing you notice is HCl is the limiting factor while calcium carbonate is in excess. Now just a second. Now read the options on this page. Which row gives the correct explanation about these results? Why the reaction stops? Because HCl is used up. So first thing you clear is HCl is used up. And why the rate of reaction changes with time? Now the rate of reaction changes with time. Now highlight the words changes with time. The rate of reaction initially is the highest because more collisions between reacting molecules occurs, but it changes with time because now fewer collisions occur between the reacting molecules. That is why the rate of molecule decreases, and then eventually becomes constant after 210 seconds. So fewer collisions between the reactant molecules causes the rate of reaction to change with time. It decreases over time. So B is your right answer. Simply is that. The Boltzmann distribution for the hydrogenation of an alkene at a particular temperature in the absence of catalyst is shown. So which row correctly describes the effect of adding nickel to the reaction vessel? Now you may have studied this reaction in your 10th class or in your O2 or O3 in the organic chemistry chapter, that alkene is catalyzed to alkanes. If I'm correct, I cannot certainly truly remember what it was, but it was something of catalysis of an alkene at 250 degrees C to, I guess, make a lipid. Yes, hydrogenation means it is making a lipid. Yes, I'm true. I'm correct. So when you add nickel, it is acting as a catalyst. The shape of the Boltzmann distribution doesn't change. I told you. I already told you that activation energy certainly doesn't affect the number of molecules possessing a particular energy. It only lowers the activation energy as shown in C. So C is your right answer. The catalyst does lower the activation energy but doesn't cause any reacting molecules to, to change their kinetic energy, certainly kinetic energy or their overall energy. So C is your right answer. So question number 14. Which row is an example of heterogeneous catalysis? So this is a good question. Reaction in esterification, catalyst is sulfuric acid. The contact process. Now you have studied contact process in your O levels. Ignore all the others. Ignore all the others. Contact process. In contact process, SO3 is converted into SO2 is converted into SO3 in the presence of vanadium pentoxide V2O5, which is a solid, while all these reactants are in gases. So this is an example of heterogeneous catalysis. B is your right answer. So question number 15 is, the diagram shows the Boltzmann distribution of energies in a gas. The gas undergoes the reaction with an activation energy E. The peak of the distribution is labeled P. If the same reaction is carried out in the presence of catalyst, which statement is correct? Again, I'm stating once again, catalyst has nothing to do with the change in number of molecules possessing a particular amount of energy. The peak P must remain at the same height, while the catalyst lowers the activation energy, so the position of EA should move to the left. So C is your right answer. So question number 16, I guess it's a repetition of question number 5. So this is the Boltzmann distribution curve once again, and for the sample of molecules of a gas at two different temperatures, which letter on the axis represents the most probable energy for a gas at lower temperature. On the y-axis you have got number of molecules, here you have got energy. So at lower temperature, more molecules have lesser kinetic energy, or you can simply say they have lesser energy. More molecules have lesser energy, so this region of the graph must be greater, while in comparison to B, I mean this shows more particles, more reactant molecules with lesser energy because it's at a lower temperature. So you got to select between A or C. While I have told you it is N, the number of moles or number of atoms or the particles, whatever it is. On the y-axis it is energy, on the x-axis which is taken. So C is your right answer. This is once again a repetition of question number 7. Question number, I guess it's question number 6. So you go on and check question number 6. I'm not explaining this once again. It is C. I know it's C. C is the right answer. I guess he has given the repetition once again. Let me just check the pattern of this paper. So now there is a minute change. The concept overall are limited to only 3 to 4 concepts. Reaction kinetics is the most easiest. No, it's the easiest chapter. It is the most piece of a cake of a chapter. Literally, it's a piece of cake. One should attempt 36 by 36 of it and clearly go 36 by 36. There's no doubt you should be attempting even one MCQ wrong. All should be correct. The diagram shows the Boltzmann distribution energy of for a reactant gas for a particular reaction. The activation energy is X. So which change to the diagram occurs if an effective catalyst is added? Activation energy is gonna decrease. The value of activation energy decreases. D is your right answer. Alright, so 19 appears to be a new question. A large excess of magnesium ribbon is added to dilute HCl, so magnesium is in excess, and a volume of hydrogen gas produced is measured as the reaction proceeds. The reaction is exothermic. The results are shown. Which row explains the changes in rate of reaction between points P and Q and between Q and R? So between points Q and R in this region, now he has told that the magnesium is in excess, so ignore A, ignore B and D. So the acid concentration must be falling, whereas the reaction is exothermic. D is incorrect because magnesium surface area, he has told us that magnesium is in the ribbon form and it is large in excess, so magnesium surface area must not be taken into account here. So you're only left with A actually, but the reaction temperature is increasing. There are increased collisions between the reactant molecules. So the rate of reaction increased between P and Q in this region. So A is your right answer. Question number 20. The measurements are made to determine the activation energy EA of a reaction. The diagram shows EA on the Boltzmann distribution at temperature T1. Measurements are made at a higher temperature T2. So which diagram correctly shows the Boltzmann distribution and EA at T2? I had told you already, temperature has nothing to do with activation energy. So activation energy is going to stay the same. So you definitely ignore B and D. Now, you are increasing the temperature, you are increasing the number of molecules with kinetic energy. So there would be more molecules now possessing more kinetic energy as shown in graph A. Unlike C is a copy paste of this graph. Actually, you are increasing the temperature, you are increasing the kinetic energy. So that's why there are now more number of molecules possessing more energy. So A is your right answer. So the reaction pathway diagram for a reversible reaction is shown. Which statement is correct? Okay, so activation energy of the reverse reaction is plus 80 kilojoule per mole. So this is the forward reaction. So this whole is 80. So for the reverse it must be negative. So this is an exothermic reaction, so this is a minus 80. So for the reverse it must be plus 80. So he is true here actually. Enthalpy change for forward reaction is plus 30. No, enthalpy change for forward reaction is minus 50. Enthalpy change for reverse reaction is minus 80 and it is 50 here, I guess. Yes, 50. Minus 80 and minus 15. Enthalpy change for reverse reaction is gonna be plus 80 and then you are decreasing 30. So the enthalpy change for reverse reaction is 50 kilojoule per mole, unlike D. So A is your right answer. The activation energy for the reverse reaction is plus 80 kilojoule per mole. H2O2 decomposes to form water and oxygen. The reaction is catalyzed by the bromide ions. So they both are aqueous. So it must be a homogeneous catalysis. And which row is correct? In step 1, the bromine ions, they lose electrons, so they are oxidized. Loss of oxygen, loss of electron is oxidation. So C is your right answer. So we'll move on to question number 23. Question number 23 says the Boltzmann distribution for 1 mole of a gas at temperature T is shown. So 1 mole of the same gas is added to the reaction mixture and the gas remains at temperature T, no change in temperature. Which dotted curve shows the distribution with the added gas? A. Categorically A is true. Why? Because there are more number of particles. This is true. There are more number of particles, but they possess the same energy. They possess the same energy. This is the actual difference here. So A is your right answer. All other options are incorrect. I repeat, you are increasing the number of gas particles, so there would be more particles possessing the same energy because the temperature is the same. Anyways, question number 24. In the reaction shown, the concentration of both X and Y are reduced to half of their original values, whilst keeping the total volume of the solution constant. The concentration of X and Y to are reduced to half their original values. Done. So this is the reaction, and you have now decreased its concentration of the reactants. So simultaneously the temperature is increased from 298 to 348 Kelvin. Which prediction is definitely true? A smaller proportion of successful collisions between particles of X and Y will be successful. Now you have decreased the concentration, but you have increased the temperature. So you are 50-50 now about how to approach this. So ignore A for some time. The average kinetic energy of particles of X and particles of Y will increase. Definitely it's true. The active the average kinetic energy is definitely increasing here. More particles will be possessing energy more than the activation energy. So the average kinetic energy must increase. The rate of collisions will be unaffected. It will be affected. The frequency of collision will half. Now you have increased temperature, so this is also incorrect. So definitely B is your right answer. Question number 25. The Boltzmann distribution for a gas at constant temperature of 50 degrees C is shown. So we have already done this MCQ. This is MCQ number 1. Definite. I guess it is at the start of the paper. Yes, it is. So I'm not gonna repeat it. It is B. Go and check MCQ number 1 at the start of the video. So MCQ number 26. A large amount of N2O gas is decomposed into nitrogen gas and oxygen in the presence of a tiny gold catalyst. Gold catalyst provides a solid surface on which the catalyzed reaction takes place. So this is the uh, catalyst here, the heterogeneous catalyst. The graph shows the concentration of N2O against time as it decomposes. The graph is a straight line, means that the rate of reaction is linear. It doesn't change, it is constant. Which row describes the change in the reaction as N2O decomposes from 0 to 10 minutes? It is same. Changes in reaction is none. And you add the gold foil, then the rate of reaction is definitely gonna increase. Piece of cake. A is your right answer. So we jump directly to the 30th MCQ. Ignore the MCQs between. They are not much important. The diagram shows the Boltzmann distribution of energy in the gas. The gas can take part in the reaction with activation energy. The gas is maintained at a constant temperature. Which statement is correct? If which statement is correct when just a second. Okay, now. So you are adding catalysts. Catalyst. 4 catalyst. Okay, so the peak will be the same. Yes, the peak will be the same. I repeat, for I guess the 15th time now, that activation energy, sorry, the catalyst has nothing to do with the molecules possessing a particular amount of energy, and activation energy will move to the left because activation energy is decreased. So C is your right answer. Question number 31. The rate of an exothermic reaction is followed by measuring the concentration of a reactant at regular time intervals. During the experiment, the temperature of the reaction mixture is not controlled. Which graph shows the change in concentration against time? The rate of an exothermic reaction is followed by measuring the concentration of reactant at regular time intervals. During the experiment, the temperature of the reaction mixture is not controlled. Which graph shows the change in concentration of reactant against time? It's an exothermic reaction. The concentration will decrease over time. It is an exothermic reaction. Temperature of the reaction mixture is not controlled. So this is definitely not a straight line graph. It is not a straight line graph, and the concentration of reactant is never increasing. So among C and B, you have to check the trends here. The gradient is here, it is increasing, and here the gradient is decreasing. Here the gradient is decreasing with decreasing rate, decreasing with decreasing rate, and increasing with increasing rate somehow. Now you cannot certainly predict the value, or you can certainly cannot predict a shape of the graph, like it is decreasing with a decreasing gradient and becomes constant. The reason is you are not monitoring the temperature here. If the temperature is monitored, then definitely you can do what actually should happen here, but this must be an irregular trend. This must be an irregular trend. That's what my philosophy says. So B is your right answer. Question number 32, part 32. For a particular reversible reaction, the backward reaction is endothermic. The activation energy of the backward reaction is 160 kilojoule per mole. Okay, it can be zoomed at backward reaction processes by a mechanism that is exact reverse of the mechanism for the forward reaction. Which statement about the activation energy of the forward reaction is correct? The activation energy of the forward reaction is 0 kilojoule per mole, but less than 160. The activation energy of the forward reaction is minus 160. Let me just draw a profile here. It's like this. So this is 160. 160. Activation energy of the forward reaction is equal to minus 160. No, it should never be. Activation energy of the forward reaction is equal to plus 160. No, again it is not. Activation energy of the forward reaction is greater than 160 kilojoule. Now it is smaller than 160 kilojoule per mole. It is smaller than 160 kilojoule per mole. The activation energy of the forward reaction is 0 kilojoule per mole. How is this? Is this possible? Like then it should be like this. It can be possible, because some reactions they may do not have an activation energy. They will immediately you put them and they react. So this can be possible, but the part later on in the statement is less than 160 must be true. So B is your right answer. I'm gonna go with B. Question number 33. Diagram show the Boltzmann distribution of energies of gaseous molecules at a particular temperature. Which statement is correct? If the temperature, so if the temperature is raised, you are raising the temperature, the maximum of the curve moves to the right, the maximum of the curve increases. Is this gonna increase or it is gonna move to the right? It is gonna move to the right, because you are now increasing the kinetic energy. Repeating this for, I guess, the 20th time now. You are increasing the kinetic energy. Hope somebody has watched this whole video. When increasing the kinetic energy, so there would be more molecules to the right of the graph. So B is your right answer. All other are incorrect. Line labeled Y show the enthalpy change. No, it doesn't. It doesn't show the activation energy. Okay. Question number 34. In reaction 1, a student measures the initial production of CO2 when calcium carbonate is added to 50 centimeter cube of 0.1 mole per decimeter cube HNO3. When in the second experiment, student repeats the experiment using 50 centimeter cube of 0.5 mole per decimeter cube HNO3. So the concentration has increased here, and the same mass of calcium carbonate. In the reaction 2, in the reaction 1 and 2, the acid is in excess and the samples of same copper carbonate are used. Which row is correct here? So the rate of reaction 1 has lower concentration of HNO3, and reaction 2 has higher concentration of HNO3. So the rate of reaction of 1 should be smaller than the rate of reaction 2. So it is less than 1 and it is less than 1 definitely, because the ratio you like 1 by 2 is obviously 0.5. The issue here is of the concentration. It is more concentrated, it is less concentrated. Initial number of effective collisions in reaction 1 per second, in reaction 2 per second. Now definitely you have increased concentration, so there would be more collisions in 2 than in 1. So this is again a smaller case, so 1 by 2, so it is definitely going to be less than 1. So D is your right answer. Identical to the part, identical to the uh, this part of the question. Okay, the decomposition of hydrogen peroxide in the presence of MnO2 produces water and oxygen gas. The volume of gas collected when 0.2 gram of MnO2 is added to two different concentration of H2O2 at 20 degrees C is shown at the graph X and Y. So which row shows the condition that will result in curves X and Y? X is X is more concentrated definitely, because the curve is a straight line. No, it is not more concentrated. Let me just check this for once. So I'm gonna back solve this. I'll be checking every option. If we check A, the volume of H2O2 is 50, 0.1, 50 and 0.2. So X is less concentrated, Y is more concentrated, and in Y it is in powdered form, whereas in A it is in lumps. No, this is incorrect. The reason is the powder and the lumps issue. If if the positions was reversed, then A would have been true, because there's a greater difference in their rates here. So yeah, A is incorrect. 25 and 0.2, 25 and 0.1. So this is curve X is more concentrated. Now if it is more concentrated and it is in powdered form, no, this is again incorrect. It should never, then it should be in place of X. B is also incorrect. Part C, 50 and 0.1, 20 and 0.22. Let's check me this. 50 and 0.1, this would become like 0.05 for 25. If we divide this by 2, and this is 0.2 for 20. So this is more concentrated, this it is less concentrated. It is in lumps. Curve X is in lumps and curve Y is in powdered form. So yes, C can be our right option. Check part D. There is 20 and 0.2, 40 and 0.1. So 20 and 0.05. So curve Y is less concentrated. No, this is again incorrect. C is your right option. Last MCQ. Heading on to the last MCQ. Okay, now question number 36. Two experiments carried out to study the reaction between zinc and sulfuric acid. Small lumps of zinc were added to excess diluted sulfuric acid. The reaction is carried out at a lower temperature and with one other change. Both produce the same volume of gas and are completed in the same time, so the rate of reaction is the same and the same volume of gas is produced. What change is made to the experiment 2? A greater mass of zinc and the greater volume of zinc would cause issues in the stoichiometry, and larger lumps of zinc used means that the rate of catalysis would be, there would be rate of catalysis, but it would be comparatively less when when the powdered zinc is used. Now that is zinc is a reactant here, so larger lumps would cause the reaction rate to even decrease. So you're only left with A. You are adding a catalyst. This will allow it to be completed in the same amount of time. So A is your right answer. It took me 40 minutes to solve these 36 MCQs. I hope you have understood. Take care. Goodbye. Allah Hafiz.